Hello all. In this lecture, we will see how to map this entity relationship diagram into relations. So we have already seen the high level view of the database design. That is, we have already seen how to draw entity relationship diagram. So that is a high level view of the database design. So next step is to design it logically. That is, we have to convert it into logical database design. That is, we have to convert that ER diagram into relations. So in this lecture, you will see how to do that, how to convert this high level ER diagram into relations. So this is a outline. So we have an ER to relational mapping algorithm which consists of 7 steps. So actually it's not 7 steps. If we have to study the enhanced entity relationship diagram, there is EER diagram. So if we have drawn that EER diagram, then we need to convert that EER to also relations. But as per your syllabus, you have to learn only ER diagrams. So we have only 7 steps to convert it into relations. So in step 1, we will be mapping the regular entity types or the strong entity types. Then weak will be second step, we will map weak entity types. Step 3, we will map binary relationships, 1 is to 1. Then step 4, 1 is to n. Then step 5, m is to n. And step 6, mapping multi-valued attributes. And step 7, n-array relations, that is more than one, that is not binary if it is ternary or other type of relationships. So these are the 7 steps. So this is a ER diagram of the company database that we have designed. So we know what is this ER diagram. So we know which are the entity types. Those who are not aware, you can refer the previous lectures and learn how to draw this entity relationship diagram. So after drawing this entity relationship diagram, we need to map it into relations. That is, we have to convert like this. So we have to map this ER diagram to this relational data model. So that is what we are going to study in this lecture. So recap all those things. You have to recap. So this is a strong entity. So this is a weak entity. So these are relations. Then this is derived attribute. This is an attribute of this relationship. Remember all these things. So this represents a multi-valued attribute, and this represent a composite attribute. Name represent a composite attribute which consists of symbol attributes. Then we have already seen what is this total participation. If there is double lines, it means total participation. Then we have seen 1 is to n relationship, 1 is to 1 relationship, then m is to n. Then this is recursive relationship. So all these things we have seen. So underline, those underline will represent the key, primary key or the key attribute. So we have already seen all those things. So we have to map this thing to this relations. So these are the different relations that will be formed when we map this ER diagram to relations. So this is the logical database design, and this is the high level conceptual design. So we have to map this high level conceptual to this lower level, so or logical database design. For that we have a 7-step algorithm. So in that 7-step algorithm, what we do is we will convert the basic ER model constructs, that is entity types, strong and weak, then binary relationship with structural constraints, and n-array relationships, also attributes, the different types of attributes, simple attribute, composite attribute, and multivariate attribute. So we will convert all these ER model constructs to relations. We have to form relations. So we know what is a relation. It is a table. So we have to convert it into tables. So first step, it is to mapping of regular entity types. In step 2, we will map weak entity types. In step 3, we will be mapping binary 1 is to 1 relation types. Then map after step 4, we will map 1 is to n relationship types. Then step 5, we will map m is to n relationship types. And step 6, we will map multi-valued attributes. And in step 7, we will map n-array relationship, that is ternary relationship, and all we will map in 7th step. So this is a 7-step algorithm. So we will see each step with examples. Then you will understand how to convert this. So step 1, it is mapping of regular entity types. So whenever there is a regular entity or strong entity type, we can call it as E in the entity relationship diagram. So what we have to do is we have to create a relation. So we have to create a table R that includes all the symbol attributes of E. So all the symbol attributes should be there in that table. Then choose one of the key attributes. There may be several key attributes in that table. So we have to choose any one of the key attributes of E as the primary key for that relation. Then if the chosen key of E is composite, if we have chosen a key which is composite, so remember what is a composite attribute? It consists of many simple attributes. So if it is a composite key attribute, then the set of simple attributes that form it will together form the primary key of R. So that is what we have to do. So in this ER diagram, we have to identify the strong entity types. So if we check, we know employee is a strong entity, then department is a strong entity, project is a strong entity. So we have three strong entities or three regular entities. So we have to convert that in first step. So employee and all the attributes should be included. So SSN, birth date, the name, address, salary, and sex all together will form the attributes, and we can split the name into three composite attributes. So we have to remove this name composite attribute and make it as three simple attributes. So so that will form the first employee. So if we see this will be the employee table. Sorry, this will be the employee relation. First name, middle initial, last name, then SSN. So here we have only one key attribute. SSN is the key attribute. So SSN will form the primary key of this table. Primary key of this table. So birth date, address, sex, and salary. So this is step 1. Then the second strong entity is department. So department, we have the simple attributes are name and number. Here locations is a multi-valued attribute. So we should not do anything with a multi-valued attribute. We have not mentioned anything about multi-valued attribute. We will see what to do with multi-valued attribute in step 6. So we will simply leave these locations and you will take only name and number. So that department and department name and number will be taken, and name is a key attribute, number is also a key attribute. So you can take any one of these attribute and make it as a primary key. So we have taken D number as the primary key. Okay. Then the third strong entity is project. So project, and it has three attributes: name, number, and location. Here name and number are both key attributes. You can take any one and keep it as a key attribute. Okay. So here project, P name, P number, and P location. And we have taken P number as a key attribute. So you can change the name also. Okay. So we here it is name and number. We have changed it to P name and P number. So we can change the attribute name. Here similarly department, here name and number. We have changed it to department name and department number. So we have changed to D name and D number. So you can change the name of the attributes and all. It is not a problem. So in first step we have to convert the strong entities or regular entities, that is employee, department, and project, to relations. So we have formed three tables. Okay, so this is after step 1. Then in second step, what we have to do, we have to map weak entity types. So in the previous, in this example, we have only one weak entity type, that is dependent. So how to map it into a relation? So what we have to do is, for each weak entity W, we can call it as W, it will have an owner entity E. So we have already seen. So this dependent, it is a weak entity, it should have an owner. So here employee is the owner of it. Okay. So we have to create a relation R and include all symbol attributes of W. So we have to include all the symbol attributes of W as attributes of the new table. In addition, we have to include as foreign key. So we have to include in this relation a foreign key attribute of R, the primary key or attribute of the relation that corresponds to the entity E. Okay, I'll show an example, then you will understand it. So what you have to do is we have to take a foreign key attribute for this relation, for the newly formed relation, and that foreign key attribute should be the primary key attribute of the owner entity E. Okay, so we have to make a foreign key. Then what should be the primary key of our newly formed R? So the primary key of R is the combination of primary keys of the owner and the partial key of the weak entity if we have any. So you'll see this example, then you will understand what we have written. So here dependent is a weak attribute, sorry, a weak entity. So what we have to do is we have to form a relation dependent. So we will call it as dependent, and we will have the attributes dependent name, then sex, birth date, and relationship. So that is what is mentioned here. So with all simple attributes, we have to form a relation. Then what you have to do, we have to include a foreign key attribute for this R, and that foreign key should be the primary key of entity for of the owner. So we have to include a foreign key. So in addition to these four attributes, we will include another one attribute here, and that will be the foreign key, and that foreign key will be the primary key of this owner entity. So employees SSN should be included in this dependent. Okay, so that is what we have done here. So ESSN is included here. So actually were only four attributes. We have included the SSN value also here. So SSN will form the, so we have just changed the name to ESSN. Okay, we can change the name. So we have included this SSN to dependent table. Okay, so that is what is mentioned here. So we have included a foreign key. Then we have mentioned one more thing. What should be the primary key of the new table? So primary key is a combination of primary key of the owner and the partial key. So here the partial key is name, and primary key of this one is SSN. So the combination of this SSN plus name will form the primary key of this table. So after step 2, we will get the table like this. So ESSN here, the primary key of this table is the combination of ESSN and dependent name. So this together will form the primary key of this table. And these are the three other attributes. Here we may or may not split this dependent name into first name, second name, and initial. It is not mandatory that you should split it into simple attribute. If you want, you can split it into simple attribute. If you are splitting into simple attributes, then it will the four attributes together, the three attributes of the name plus ESSN together will form the primary key. It's not necessary that you should split everything. So here this will form the primary key of this thing. Now the table will become, now the relation will become like this. So we will have employee, department, and project we form from the step 1, and after step 2 this relation will also be added. So now we have 4 relations. Okay, then step 3, what we have to do is we have to map binary 1:1 relationship types. So we have to map binary 1:1 relationship types. So if we see, we have only one 1:1 relationship, that is manages. Manages is a 1:1 relationship type. So how to map this thing? So what we have to do is for each binary 1:1 relationship type R in this relation schema, what we have to do is identify the relation S and T. So we will call it as S and T. We can call any of this relation. So we have two entities here. One is employee and department. So we can call this one as S and this one as T, or this one as T, this one as T, and this one as S. You can take any. Okay. So how to call that we will see. So identify the relations S and T that correspond to the entity types participating in R. Okay. Then we have three possible approaches to convert it into relation. So first approach we will see, we call it as foreign key approach. So in foreign key approach, we will choose one of the relations as S. Okay. And what we have to do is include a foreign key in S, the primary key of T. So we know that there are S and T. So we have to do, what we have to do is include a foreign key in S, the primary key of T. So it is better to choose an entity type with total participation in R in the role of S. So we will see and that example, then you will understand. So we have 1:1 as manages is a 1:1 relationship. So we have employee and department as the participating entities or the participating relations. So what we have to do is, in the foreign key approach, we have to choose one of the relation as S. So we can choose either this one as S or this one as S. But it is better to choose an entity type with total participation in R as the role of S. So if we see, there is double line. So double line means department has total participation in this relation. So it is better to choose department as S part. So we have to choose this as S and this as T. Okay, it is not mandatory. You can either make this as S and or this as S. But if there is a total participation, then it is better to choose department as the S part. Okay, so what we have to do? So we have to include a foreign key in S, the primary key of T. So what we have to do is, we have to include, we have already formed a department table. So we have to include a foreign key in department. What should be the foreign key? It should be the primary key of this one. So we have to include this SSN in department. So after step 3, so if we see this 1:1, manages is mapped by choosing the participating entity department to serve in the role of S, because its participation in the manager's relation type is total. So that is why we have chosen department as in the role of S. So this is the initial table that we have designed. So what we have to do is, we have to include one more attribute here. What is that attribute? That is a foreign key of to this table. So SSN should be included here. So we will include like this. So we will include this department manager SSN. Department relation will become department name, department number, and manager SSN will be included. So we have changed that name SSN to manager SSN, because every department there will be a manager. So we have included that attribute here, department manager SSN. So this department relation has changed to department name, department number, department manager SSN. And if you see this table, we can see that there is another one. Start date is there in this managers relationship. So in this relationship, there is another attribute, start date. So that start date should also be included here. That is why I have included that manager start date as an attribute here. So now this department relation will be changed to this one. So the rest of the things are same. Employee, project, dependent is the same. But department has changed to like this. So this is the foreign key approach. Okay. So in this foreign key approach, what you have to do? We have to include a foreign key in this department table in the S part. If there is total participation, so department has total participation, so we have taken department as the S part. So we have to include a foreign key. What should be the foreign key? It should be the primary key of this thing. So SSN will be included here. So we have simply changed the name to manager SSN. And if there are any other attributes in that relationship, that should be also be included. So department relation will be like this. And this is the first approach. Okay, so I have mentioned that there are three possible approaches. This is foreign key approach. Then there are two other ways to convert that thing. This is foreign key approach. Then the second one thing is, we call it as merged relation option. So what we do is, we will simply merge the two entity types and the relationship into a single relation. So in certain cases, what we can do is we can simply merge these together. That is, employee and department will be merged together and it will form a single relation. But in this case, it won't be good because there will be many null values in that relation. Okay, it won't be good. Okay, we can either follow this first approach, or in some cases, we will follow this second approach. We will simply merge those two relations together to form a single relation. It is appropriate when both participations are total. So if there is total participation from both the sides, then this merged approach will be better. Then third technique is there to convert. That is, we call it as cross reference or relationship relation option. So what we do here is we set up a third relation, R. We can call it by any name for the purpose of cross referencing the primary keys of the two relations S and T representing the entity types. So in this approach, what we do is we have this employee. Okay, we will have this employee, department, project dependent, and we will form a new table. We can call it as anything, M department, something we will call it as M department. And in that table, what we will include is we will include the primary key of department and employee. So we will include D number and SSN, and we will form a new table. Okay, so in that table, there will be two attributes, D number and SSN, and that combination will form the primary key of that table. So a fifth table will be formed. Okay, we won't be following that approach because what happens is the number of tables or the number of relations will be increased. Here, in the foreign key approach, the number of tables won't change. If it is 4, it will be 4 itself. So in the third approach, what happens is a new relation will be formed. So that is known as cross reference. Okay, so we will set up a third relation for the purpose of cross referencing the primary keys of the two relations S and T. So we will take the primary keys of S and T and form a new relation. So that is all about step 3. Then next it is step 4, how to map binary 1:n relationship types. So what we should be done for 1:n. So for each regular binary 1:n relationship type, what we have to do is identify the relation S that represents the participating entity at the n side. So n side we call it as S. Okay. So in this 1:n, the n side we will call it as S. So in that S, what you have to do is include as foreign key in S the primary key of the relation T. So in this 1:n, n side will be called S and one side will be called T. So in the n side S, we have to include the primary key of T. So the primary key of T will be included in the n side. Okay. So include any symbol attributes. If there are any symbol attributes in this relationship type, that will also be included in the S relationship. So we will see an example, then you will understand what is this. So in this example, we have many 1:n relationship. So we have works for is a 1:n relationship. Then we have this dependence or the supervisor. We should not take this one. This is not a regular 1:n. This is an identifying relationship. We have already seen this. So we have works for relationship type. It is a 1:n. Then controls. It is a 1:n relationship type. Then this supervisor. This is a 1:n relationship type. So we will see there is works for, controls, and supervision. So what should be done for works for relationship type? So what we have mentioned is we have to take the N part. So employee part should be taken as a S. So this is S and this is T. So in the S part, what should be done? We have to include a foreign key for this employee, and that foreign key should be the primary key of this table. So the primary key of this table is department number. So department number should be included in the employee table as a foreign key. So in this works for, what we have to do is this is the initial table. So works for is between employee and department. So what should we do is, this will be the S part, and this employee part we have to include an attribute. A foreign key should be included, and that foreign key should be the primary key of this department. So primary key of this department is D number. So this will be included in this table, and so D number will be added to the employee table. So this is the foreign key of this table. Okay, so that is what is happening when we convert this works for into relation. So this D number will be the foreign key to this table. So that will be included here. So this employee table will be like this. Okay. Then also we have mentioned, if there are any attributes also, that can also be included. There are no attributes in this works for relation, so it can be included. So that is a thing we will do. Then we have controls relation. So controls relationship, that's also a 1 is to n relationship. So 1 is to n. So we will see this controls. So controls is a 1 is to n relationship. So what we have to do with the controls relationship? So we have to take the n side. So n side is project, and in project we have name, number, and location is there. And what we have to do in this relation, we have to include a foreign key, and that foreign key should be the primary key of this relation. So the primary key of this relation is department number. So department number should be included in the project table. So initially we didn't have the department number here. So after this, D number will also be included in the project table. So this D number is the foreign key of this table, and this is the primary key of this table. Okay. Now we have one more 1 is to relationship, that is the supervision. So what should be done with the supervision? So supervision is a relationship, a recursive relationship, that is from employee to employee. So it is a 1 is to n relationship. What we have to do? We have to include in the n side. N side is employee itself. So in the n side, what we have to include? We have to include a foreign key. So we have to include a foreign key in employee itself. What should be the foreign key? The primary key of employee itself. So SSN should be included as foreign key also. Here, since it is supervision, we can make it as a supervisor SSN. We can make it SSSN. So that is what we do in this step. So super SSN is included as another attribute. So the employee table will become, we'll add one more attribute, that is super SSN. So super SSN is a foreign key, and that foreign key refers the SSN of that table itself. Okay. So this is what happens after step 4. So after step 4, the employee table will become like this. So super SSN and DA number will be added. Department, there won't be any change. And in project, we will add one more attribute, D number will be added, and dependent will remain the same. So this is after step 4. Okay. Then next is step 5. So in step 5, we'll be mapping the binary M is to N relationship type. Okay. So in this example, if you see, we have one M is to N, that is works on is an M is to N relationship type. So what we have to do with that relationship? Okay. So for each regular binary M is to N relationship type, we have to create a new relation. So here we are not going to add any attribute. So we are creating a new relation. We can call it as S. So a new table will be created. And in that table, we have to include foreign key attributes in S, the primary keys of the relations that represents the participating entity. Since we have formed a new relation, so in that new relation, we will have foreign key attributes. What are the foreign key attributes? It will be the primary keys of the participating entity types. So you will see an example, then you will understand. And their combination will form the primary key of S. And if there are any simple attributes in that M is to N relationship type, then include also all those attributes in S. So we'll see this example, then you will understand what we have written. So we have works on relation, it is an M is to N. So what we should do, we have to create a new relation. We can call it as works on, a table, new table, works on table will be formed. And in that table, what we have to include? We have to include foreign keys of foreign keys. What should be the foreign keys? The primary key of employee and also the primary key of project. So primary key of employee is SSN. So XSN will be there in the works on, and also the primary key of project is P number. So P number will also be in works on. And also what should be there? Last step. So here the combination will be the primary key. So the combination of SSN and P number will be the primary key of that table. And also in the last step, what you have mentioned, simple attributes. If there are any simple attributes in this relationship, that should also be included. So here hours is a simple attribute of works end. So that hours will also be included in the table. So after step 5, we will form a table like this. So works on table will be formed. So SSN is the primary key of employee and P number is the primary key of project. So primary project we have P number. So we will include P number and SSN in works on, and additionally hours. So additionally we will include this hours also in this table. So this will form a new relation S. We call it as works on, and the combination of these two attributes, ESSN comma P number, this combination will be the primary key of this table. Okay, so this combination will be the primary key of this table. So now the relation will be like this. So employee will be there, department will be there, project will be there, dependent, and a new relation will be added to the whole design. So works on will be added to the relation. So after step 5, we will have 5 tables or 5 relations. Okay. So this is the initial design. Then we will see in step 6. So we have to map multi-valued attributes. So if you check in this, we have a locations as multi-valued attribute. We have not added to any of these tables. So we have to do something to this locations. So that is done in step 6. What we have to do with multi-valued attributes. So for each multi-valued attribute, what we have to do is we will create a new relation. So a new table will be formed, and in that table include an attribute corresponding to this A. So this attribute will be added to this new relation. We can name it anything. Plus the primary key attribute K should be included as a foreign key in R of the relation that represents the entity types of a relationship T that has an A as an attribute. The primary key of R is a combination of A and K. We will see an example, then we'll understand. And if the multivalued attribute is composite, we can make it into simple components also. We will see that example, how to convert these locations. So what we have mentioned is, so if there is a if there is a multivalued attribute, what we have to do is, we have to form a new relation. So what that relation, we can name it as department locations, a new table, department locations. And in that we will include this locations attribute, plus we will include the primary key of this department. The primary key of department is department number. So department number comma department locations will form a new table. So this we will call it as department locations. A new relation will be formed, and department number is the primary key, department foreign key, and department location is the multi-valued attribute. This together will form the primary key of this table. So this combination will form the primary key of this table. So that is what we have written. So we will include that attribute A in that relation R, and plus the primary key of K will be included as a foreign key. So here department number is the primary key of that table. That will also be included here in this table R. Then what will be the primary key of this new table? It is a combination of A and K. Okay. And if there are multivalued attribute is composite, then we can split into simple components. Here department location, it is not a composite attribute, so we need not split. So this will form the new table. So finally the design will be like this. So employee will be there, department will be there. Now we have included a new table, new relation into this. So department locations will be there, then project works on dependent. So 1, 2, 3, 4, 5, 6 tables will be there, or 6 relations will be there after step 6. So this is the final logic design. So this is the final design of that ER diagram, that company database. If we try to do all the steps, then it will be converted into this 6 tables. So in this way, we can map the ER diagrams into relations. And step 7 is there, but in our example there is no ternary relationship in our example. So if there is a ternary relationship, when you do your assignment there may be some ternary relation. So if there is such a n array relationship type, that is n greater than 2, it may be ternary or more than 2. What we have to do is we have to create a new relationship S to represent this ternary relationship or the n-array relationship, and we have to include as foreign key attributes in S the primary keys of the relations that represents the participating entity types. So all the primary. So if there are 3 relations, if a ternary relation is there, then it means we have 3 entity types. So we have to take the primary keys of all the 3 entity and make it the foreign key of S, and also include any simple attributes of S in that relation. So you will see an example, then you will understand what we are. So we have already seen in the previous lecture that supply is an example for ternary relationship. We have supplier as another entity type, project is an entity type, and part is an entity type. So we have 3 entity types in this relationship. So what we have to do? So when we convert it into, or when we map it into relation, so we'll create a new relation, we can call it as supply, and in that supply we will have foreign keys. So what are the foreign keys? The primary keys of the entity types, that is S name, part number, and project name will be the foreign key of that supply, and also this quantity will also be added to supply. So the final supply table will be like this. So supply will have like this. So supplier, that S name and some other attributes will be there, and project also, that project name will be the attribute and all other attributes will be there. Then part is another table and part number, and if there are any other attributes, all those attributes will also be there. And we have formed a new supply relation, and in it we include S name, it is a primary attribute, primary key of this table. Project name, it is a primary key of this table. Part number, it is a primary key of this table. All these 3 will be included in the supply, and this combination of these 3 attributes will form the primary key of the supply. And additionally, if there are any attributes for this supply, we have a quantity, that attribute will also be included in this table. So we can convert a ternary relationship like this. If it is n-ary, if there is more than one entity, we have to, what we have to do, we have to include the primary key in this table, and the combination of that 4 attributes will form the primary key. So in this way we can convert any n-ary relationship into a relation. So this way we can convert ER diagrams to relations. So this is a summary of ER notations. So this is the ER model we have studied, and how when we convert it to relational model, what happens. So entity type becomes entity relation. So 1:1 or 1:n relationship type become foreign key, or it may form a new table or relationship. We have already seen works on and all, we have formed a new relation. We can form for new relations also. Then M is to N relationship type, a new relation will be formed. Relation will be formed with 2 foreign keys. If it has an n-ary relationship, a new relation will be formed with n foreign keys. That is what we have seen in the supply thing. If it is a simple attribute, it will be changed into an ordinary attribute. If it is a composite attribute, it can be converted into a set of simple component attributes. If it's a multi-valued attribute, then it will form a new relation with a foreign key. Okay. Then if it is a value set, it will be a domain. And key attribute will become a primary key or secondary key. So we have already seen what is primary key and secondary key. So there may be several keys in a particular relation, and then all the keys are known as candidate keys. One will be kept as primary key, then the rest of the keys will be called secondary keys. So in the previous lecture we have seen the car example. In that we have car, we have the registration number and engine serial number both as candidate keys. We will take engine serial number as a primary key, then the other key will be known as a secondary key. So we have already seen this. So I have included an exercise also. You can do this exercise. So we have an ER diagram here. So what you have to do is you have to convert, you have to map this ER diagram into relations. You have to follow the 7 steps. So in the first step, you have to find out the strong entities. So strong entities are ship type, state, country, sea, ocean, lake. So we have 3 strong entities. Here one ship is also there. Ship is also a strong entity. So you have to map all those strong entities first. Then second step we have to map the weak entities. So we have ship movement, then port visit are the weak entities. So we have to convert those things. Then after that we have to convert the 1:1 relations. So in this we don't have, I think we don't have a 1:1 relationship. All are 1:n relationship. So this may be, there is no 1:1. Okay, then we have to convert 1:n. So we have many 1:n relationship. We have to convert all those 1:n to relations. Then if there are m:1, then we have to convert. If there are multi-valued attribute, if you see there are no multi-valued attribute, then we have to do nothing. So you try this exercise and you can submit in the classroom. So try to convert this ER to ER modeling. And also in the assignment side, you have already drawn the ER diagram for your project. And now we have to convert that ER diagram into relations. So that is the next part of your assignment. I will announce it later. So this is a reference. Thank you.